Hey guys, Coach Cook here. I'm going to do a video right now about Hess's law. Now remember, Hess's law is kind of a way to find enthalpy or heat in a system when there are two equations given. There's two parts to this problem. You're first going to have to combine these two equations in order to make one new equation, and then you're going to have to add these numbers to give me what the delta H is for both of them total. Okay, so let's go through this. All right, the way you do this, we got the reactants on one side and the products on the other. Okay, and since this is kind of a harder concept, I'm going to do multiple versions of this. Sammy, my boy right here, is helping me film this, so y'all can thank him in class later. But the way we do this, so we start with the reactants, and I have equation 1 and equation 2. Okay, these are both going to be given to you, and you got to combine them. So for equation 1, we got BaO first is my first reactant I see. In BaO, you're going to try to see if there's another BaO on the opposite side of the arrow to see if they cancel out. Because just like in algebra, and Sammy, if you want to get this, if you have x equals x, right, you can cancel both those things out in order for them to go away. That's what we're trying to do. So I have BaO, so I'm going to go to equation 2, opposite side of the arrow. There's no BaO, so I'm going to keep it there. SO3, I have SO3 on here, so I'm going to look on equation 2, opposite side of the arrow. Guess what? There is one, so I'm going to put a square around that. Okay, next, I go to my next reactant. Down here, only do the reactants first. I have H2SO4. Is there an H2SO4 on equation 1, opposite side of the arrow? No, there's not, so leave it. Okay, and then that's it. That's all the reactants I have in the whole entire problem. So I'm done with crossing them out. I'm going to put big X's on here. Now, the easy part, just list all the reactants first and all the products first of both equations. So the first one I come to is BaO. Next one I come to is H2SO4. Okay, and then there's no more reactants, so I move on. Go over here, I have BaSO. Okay, and then the next one I have is H2O. Real easy. So that's it. First part, I made my new equation, and now I have to do the delta H. This is the easiest part, guys. All you do is add this up. So if you do this number plus this number in your calculator, you should get something right around -140. And that's it. All right, next one, another example. Because they kind of get a little bit more difficult the more you go. So we have two equations given. I'll go ahead and put equation 1, equation 2. We have to combine them first and then find the delta H. So first things first, reactants and products, right? Reactants, products. Here's my arrow that separates it down the middle. So first reactant is C. Do I have a C on the other side that's going to make it so it cancels out? I don't. Do I have an oxygen on the other side that's going to make it cancel out? I don't. Do I have CO on the other side? I do. So I'm going to put a square around here and a square around there because they're opposites on that side of the line. Do I have an O2 on the opposite side? No, I don't. Okay, so now I got to combine everything. So here's where it gets a little weird. So I have C first for my first reactant. That's awesome. Then I have 1/2 O2. It's my next one. And then I have another 1/2 O2 left over. We're going to come back to that in a second. Then the last one I have for my products is CO2. Now, that looks a little funky. Okay, so anytime that you have two elements on the same side, because they're both on this side of the arrow, okay, and they're the same thing, you can add them together. You can combine them, just like you would with other types of variables. So what we're going to do now is just put these two together. So 1/2 plus 1/2 is only 1. So we're going to have 1 O2. Now technically, do I have to have that 1 in there mathematically? No. So your equation now is C plus O2, CO2. Next part, I got to come over here and I got to solve for the math for this. Just put it in the calculator, add it up, and you should get -393.5. All right, last one. So, as you guys can see, there are different variables, and they're not really elements on the periodic table, but that's okay. It's the same principle. So we have X, 2Y, 2Z, Z, X, and W. Okay, and then we made up some values over here just to give you for delta H. So let's do it the same way. Do I have an x on the opposite side of that arrow? No, I don't. Do I have a 2y on the opposite side of that arrow? No, I don't. Do I have a z on the opposite side of that arrow? Yes, I do. So I'm going to square both of those. Do I have an x on the opposite side? No, I don't. Now here's something mathematically, Sam, if you want to get this. If I have 2z mathematically and I have a z and I'm trying to subtract those, it would come out to what? 1z, right? Same thing over here. If I'm canceling out 1z and 1 from both of these, I'm going to have 1z left over. So that's why I'm going to need to remember that for when I write these down. The 2z's over here, so I'm going to keep them over here when I start writing. You'll see that in a second. So just go back through to reactants and then products, just like we've always been doing. So I have x, I have 2y, and then I have this z canceled out. So I have another x, and then I have a z, right, because it's left over, and then I have a w. Now I have an x and an x. Remember what we said. We can erase one of them, add them together. So 2x plus 2y equals z plus x, or w, excuse me. Then, last part, just come back over here and you do the math, and it's actually kind of funny. It's the same thing as the other one once you add these up. All right, so that's Hess's law. It's one of the different types of equations you're going to have to do. Remember, how do you tell you have to use Hess's law? When there are two equations and you have delta H's. All right?